Hey guys, it's Landon from Redefined Horizons and On Point Workshops. In this video, I'm going to show you quickly how you can make some basic measurements on a point cloud that comes from a UAV. So if you haven't yet, watch my video on what you can do with the UAV orthophoto. I'll try and remember to link to that in the comments or the description here on YouTube. Check that video out before you watch this one. It's the same site. I'm doing this video on the same site as I did that video. So in this video, I'm just going to show you what can you do with a UAV point cloud. Almost always at RH at Redefined Horizons, when we create a UAV orthophoto, we're also creating a UAV point cloud, and you can use that as a client to do some basic measurements. So in the first video, I showed you how you could just do some basic 2D measurements. In this video, I'm going to show you how you can do some 3D measurements, measure some heights. So I've got the point cloud loaded here. This is another free software. It's called CloudCompare. Super fantastic software. We use it a lot here at Redefined Horizons. It's free and open source. I encourage you to make a donation, help support these guys. It's a great program. You can use other programs to work with point clouds, but this is a great free tool that you can use to do that. So I've got the LiDAR point cloud loaded here. I'm not going to show you how to do that. There's a whole process that takes a little bit, but it's fairly easy, and there's you can find tutorials on YouTube and the web on how to do that. So once you get your point cloud loaded here, how do you just make some basic measurements, some basic 3D measurements? Okay, so first I'm going to just show you how you can measure, for example, the height of the building here. So I'm going to zoom in with my mouse wheel, and then I am going to hold down the left mouse button to orbit, 3D orbit. And so you can see now I'm able to 3D orbit. Now you will notice I don't have a lot of actual point returns on the faces of the buildings. And that's because of the way this point cloud was created. It was created in Correlator 3D. You can still do some basic measurements. By the way, I'm holding down hold down the left button to orbit. You can hold down the right mouse button to pan. There's some other software not free that you can use with the same basic set of data to get a better 3D point cloud that shows like the faces of the buildings. So my partner Brian likes to use a program called Context Capture. It is not cheap, it is expensive, but you can do some basic measuring with what we have here. So one other thing I want to show you is you can set your orbit. You can pick a point for your orbit, your 3D orbit. If you don't want it to be right here, you can pick a different point. For some reason I can't get that to work. Anyways, there's a way to do that here. I'm sorry that I can't figure out how to get it to work. Pick a point to be used as a rotation. Click on icon. Alright, so yeah, it's still not doing that. It's still not doing what I want. Do I gotta turn off? Let me try turning off auto. Okay, so there you go. So you have to turn off auto over here. So once you do that, you can pick your rotation point, which makes it a little easier to navigate, right? So that's helpful. Okay, so let's and don't feel bad if you're a little awkward with the 3D orbit. It takes a little bit of practice to get used to it. So let's just go in and see if we can measure the height of the building here. Now I got some shrubbery along the base of the building, but you're going to see that's okay. Let's say I want to know how tall is the roof peak above the sidewalk here. So we're going to come over here. We're going to activate the point picking tool, and I'm going to tell it I want information from, well, let me just show you. So if you just click one point in the cloud, it's going to tell you your X and your Y and your Z, so northing, easting, elevation. Now these are a little bit different. So these are truncated because it makes it easier for the software to work with the cloud. But here's your state plane coordinates, surveyors, if you're a surveyor. So it's giving you your northing, your easting, your northing, and your elevation. So we flew this on state plane in AVD88 per cores. You can see it's got the red, green, blue values for the color from the image. So that's super easy to just get that information off of one click. Okay, but let's say we want the building height, so we're going to use this tool right here, which is a 2-point click tool. And so I'm going to click here at what I think is the roof, apex of the roof. I got that a little off, didn't I? And then what I'm going to do is I'm going to just come down and click a point on the sidewalk. Now you can see if you orbit that I'm actually measuring a diagonal there. Okay, because I didn't pick the point right at the base of the building, but you can see it gives me my man, it's not doing what I wanted. I was hoping it was going to give me oh, right here. It gives me my change in Z. So you can see I've got a slope distance here of 21 feet. That's along this red line, but it's telling me my change in Z is almost 20 feet. Right, so this building was basically built to be 20 feet above the curb. Okay, let's zoom in a little bit and pan down, and we'll do the same thing here. So we'll say, all right, how far from here above the sidewalk? So we got the slope is about 10 feet. Now you can see there I got pretty close to being true vertical, so about 10 feet. You can do the same thing if you want to know how tall a tree is, for example. So I've got a tree over here. Let me reset my rotation point. Let me close this and set my rotation point. Yeah, it's still rotating. It's rotating in the wrong spot still. There we go. Nope. There we go. Okay, so you can see I've got, it's a little bit hard to tell, but I've got this evergreen tree here. So let's say I'm doing some landscape work or some, you know, I don't know, people that care about trees, whoever those people are, and I want to know how tall that tree is. Okay, so we're gonna just use the same tool, and I'm gonna click the line. I'm gonna click what I think is the top of the tree, and then I'm gonna come down here to what I think is the ground. Okay, and then if you're not sure if you got the top of the tree, you can just orbit a little bit, because you can grab the wrong stuff sometimes. You can see I got pretty close to the tree there. Now I'm measuring on a slope, but you can see right here it tells me that tree, the change in Z, or the height, the actual true straight up and down height of the tree is about 46 feet. So there's a lot of information now. Anything you see on the screen here, so this is not a photo. What we're looking at right now is not a photo. It looks like a photo, but it's not. It's actually a point cloud. If you zoom in, you can see those individual points. There's a ton of stuff you can do with these point clouds in CloudCompare, but I wanted to show you. It's really easy to just come in here and do some basic measurements. You can do the same kind of measurements too that we were doing in GeoViewer in the last video, except it'll be 3D, right? So this is a little more, it's not quite as user-friendly as GeoViewer, but it's a little more powerful, and you can get a lot of really good information out here. So there you go, CloudCompare, super cool, open source tool, works with the UAV point clouds that we get out of our UAV photogrammetry workflow here at Redefine Horizons. And if you're a client or a potential client and you think this can be useful, reach out to us. I'll put you in touch with my partner Brian. He can let you know what it takes to do this. It does require a good survey, but you can imagine, this is a pretty small site, but you can imagine on a large site like a university campus or a hospital campus how useful this could be for people in your engineering department or your facilities maintenance department or your real estate department. So yeah, reach out to us. This is super powerful. It's easy to get these data, get this type of data into your hands and get you the tools you need to actually use it. And everything we're pulling off of here is basically survey grade, right? So it's within an inch or two, maybe 2 or 3 inches vertically, but an inch or two horizontally. And so it's a super useful analysis and planning tool.